Today, my topic is all about transformer equivalent circuit. So this is just an overview. We first define what is a transformer. It is a static device by which electrical energy is being transferred from an alternating current circuit to another without change in frequency. So transformer is designed to convert alternating current from one voltage to another. It can be designed to step up or step down voltages. So you can see at the picture the transformer. The one we have here, primary circuit, the secondary circuit, and the voltage in the primary circuit, the current, the primary circuit, the number of turns in the primary circuit or the NP. The other one is the current flowing through the secondary circuit, IS, the voltage, the VS, and the number of turns, NS. Equivalent circuit of an ideal transformer. So yung diagram na yan, it is just a circuit diagram of the first one here. So yan na siya. Yung formula yan, we have already encountered that on our previous topic. The E1 is equals to, or the E1 or the induced voltage in the primary winding is equals to the 4.44 N1 frequency and times the maximum or the peak value flux in the core. You just have to memorize that formula. And this formula as well, we also encountered this, but we will use this formula if the maximum flux is given in the unit of Maxwell. We have for the example problem. The net cross-section of the core of a cycle transformer is 20 square inches. The maximum flux density in the core is 50,000 limes per square inch. There are 900 turns in the primary and 90 turns in the secondary. Determine the rated voltage of the primary and secondary. Solution. We're going to use the formula of E is equals to 4.44 NF yan, beta B A times 10 raised to negative 8. And okay, we substitute the given number or what is given in the problem. For 900 turns, we have 1,397.6 volts. And for 90 turns, we have 209.76 volts. So, ayun na siya. Then, determine rated voltage ng primary and secondary. Determine the next is the transformer representation in circuit. So, meron tayong dalawa dyan. Yung isa, the primary side, and yung isa is secondary side. So, ito, overview lang ulit to. Kasi kay Miss De Ramos to na report. Okay, so yung primary voltage V1 and the primary current I1, that current will flow through primary winding resistance R1, the primary reactance X1. I1 has two components, the no-load primary current, which is noted as I0 or IO, and the I-2. IO has two components. One has flowing through this resistance or a core loss component of no-load primary current, and the resistance or the core loss component resistance. Yung XM, magnetizing reactance, and the current flowing is magnetizing component of no load primary current I mu. The E1 is the EMF induced in a primary side, and the N1 is the number of turns in a primary winding links to the secondary turn N2. E2, for the secondary induced, secondary current I2 flow through secondary resistance R2 and the secondary reactance X2 and the load ZL. Load ZL. Okay, for in order us to analyze, we can transform it into either side of the transformer, either primary or secondary. And it is called equivalent circuit referred to primary side or equivalent circuit referred to secondary side. We have here Kirchhoff KCL I1 is equals to I naught plus I dash 2. So sabi daw, I naught is a no load primary current. Hence, it is very low. So, pwede nating interchange or i-write yung circuit as ganito. Yan. Since ganyan nga, it has a very low current, we can neglect it. So, magiging ganito yung circuit natin. Okay. Now, that is used for analysis purposes. The primary voltage V1, primary current I1, the resistance R1, the primary leakage reactance, primary leakage reactance X1, EMF induced E1, EMF induced E2, so on and so forth. So this, kapag refer to primary, yung katulad diba sabi ko kanina, we can transform the circuit diagram of either side kung primary or secondary. Kapag primary, the circuit diagram would be, yun sa refer to primary, we have now one resistance that is the equivalent resistance referred to primary, R1E, and the equivalent leakage reactance, X1E. R1E equivalent resistance referred to primary, R1E is equals to R1 plus R2 times N1 over N2 squared. X1E equivalent reactance referred to primary, X1E is equals to X1 plus X2 N1 over N2 squared. Yun naman sa referred to secondary, we have now the secondary equivalent resistance and the secondary equivalent reactance, X2E. R2E, equivalent resistance referred to secondary, R2E is equals to R2 plus R1 times N2 over N1 squared, and X2E, equivalent reactance referred to secondary, X2E, X2 plus X1 times N2 over N1 squared. I have here a example problem, but since this is just an overview, you can just browse it. Kasi nandito naman yung mga formula. You just have to input the given in the problem. So that's conclude my presentation. Thank you guys for listening, and sorry for nag-i-stutter ako. Sorry po. Bye.